In section 2.4, we're talking about addition and subtraction of fractions. So just like when we're comparing fractions, if we have the same denominator, then everything is really easy. So if the denominators are the same, we can just add the numerators together. So if we have 1/5 and 3/5, that's just 4/5. Essentially, the denominators are the things that we're counting. You know, if I have 1 apple plus 2 apples, I have 3 apples. But if I have 1 apple plus 1 banana, well, okay, that's a bad example, but you wouldn't be able to just add those together. You wouldn't be able to say you have 2 apple bananas or something like that. That just doesn't make any sense. Let's see, fractions that share the same denominator. Oh, these are called like fractions. When they have the same denominator, they're called like fractions. All right, so here's an example of 3 fractions that are like fractions because they all have the same denominator. They're all in the number of twelfths. And since I'm adding them together, they all have the same denominator, I can just add their tops. So 3 plus 1 is 4. Add that to 5, we get 9/12. And of course, we'd want to reduce our fraction here. There's a common factor of 3. When I take and divide the top and the bottom of this fraction by 3, I get 3/4. So my final answer there would be 3/4. On this one, they're all some number of ninths on the bottom, so I would take and add all those top parts together, and let's see, oops, plus 4 plus 9, that gives me 25 ninths. And I don't see any reason to convert this to a mixed number. On some of the previous problems, I had converted to mixed numbers because when we're talking about a number of fractions, that's a very common thing to do. And in general, the only advantage mixed numbers have over improper fractions is you can tell where they are on a number line, like a ruler. You can tell where they are fairly quickly. There's no indication that this needs to be converted to a mixed number, so I'm not going to. All right, if we have something like 6 plus 3 2/3, I'm not going to overthink this one because that first number doesn't have a fractional part, it's just a whole number. So I'm going to go ahead and add the 6 and the 3 here to get 9 2/3. But this is not a common shortcut that you can end up being able to do. Usually what would end up happening is you would have to convert everything to improper fractions. And that's what I'm actually going to have to do on this one. If I was to take and add these together, I'm going to start off by converting everything to fractions. So 4 1/6 is, well, 4 times 6 is 24. Add that to 1, we get 25/6. Here we get 12 plus 5 is 17/6. And here we get 18 plus 5, which is 23/6. So now I have plus, not equals. Now I have 3 fractions, all with the same denominator. I can add those fractions together really easily. 25 plus 17 plus 23 gives me 65. And let's see, looks like this is actually already in lowest terms. I can tell that because 2 and 3 are the only factors of 6. The only prime factors of 6, that is. So in order for us to cancel anything out here, it would have to either be a 2 or a 3. So this is not even, therefore it's not divisible by 2. And it is also, I'm testing, 6 plus 5 is 11. That's not divisible by 3. So that's how I was able to determine that 65 is not divisible by 3. So this is in lowest terms, 65/6. And I could leave it like that, or I could convert it back to a mixed number. I kind of feel like I should convert it to a mixed number because that's what I started with here, but there's no indication that I need to. So I'm not going to. Oops.